This time we will learn about the short channel effect. The short channel effect has various phenomenon in semiconductor device, but this time we are focused on the punch through. So before start, we have to know why the short channel effect has occurred in modern semiconductor device. For such as our smartphone or something tablet or another electric device are getting smaller and smaller, but and the performance are going higher. So for the semiconductor device, the power of consumption has lower and it has a high performance, and the device are smaller. But when the devices are getting smaller, there can occur the short channel effect. So by learning punch through phenomenon, why the short channel effect has occurred by learning about the punch through phenomenon. First, this is MFET, and when it's enhancement mode, the depletion region has made it, and when we give a drain bias from this device, and when the gate bias and drain source bias had in from this device, the channel has made it. But as I told you, the modern semiconductor device is getting smaller and smaller. So the lengths between source and drain are getting narrowing. So when we put the gate and drain source bias from this device, there has a reason that the depletion width is gathered. So even if we don't give a gate bias from this device, but there has a channel in deep substrate region, and the leakage current has made it. So this phenomenon, we call this phenomenon punch through. So let's see this graph. This graph is IDVG curve, and be aware that the scale is log. And when the channel length is plenty long, there has no problem from here. The substrate hole swings are parallel when the channel length is plenty long, but when the channel length gets shorter and shorter, the substrate chord swings are getting higher, because last time we learned that the substrate chord swings are millivolt per decade. So we know that when the channel is 1.2 micrometer length, the substrate chord swings is larger than when the long channel substrate chord swing. If the substrate chord swing is large, there has a problem, because we use the MOSFET to manipulate the turn on or turn off from switching the voltage, switching the current by using a voltage bias. But in this case, we can't control exactly, because even if the turn off state, there has already have the leakage current. So when the device is getting smaller and smaller, there has a short channel effect and punch-through phenomenon in this device. The solution is two things. First, the reason the punch-through occurs is by the depletion reason. As you know, when in MOSFET, the source and drain are heavily doped, and substrates are weakly doped. So there has a large depletion reason, but when we doped more in the substrate, the depletion reason is smaller and smaller. So we can't prevent the punch-through phenomenon. And second solution is to add some insulator like this. There has a insulator. We can also prevent the punch-through phenomenon. So like this, we can prevent the short channel effect, and by using these two solutions, we can enhance the device, and we can also make the device smaller.